What's going on, guys? Johnny Bandon, the networking guru here, and we're going to be going over domain 5.4 of our Network Plus full and free course. Like, subscribe, share it with your friends. Let's go ahead and jump right into it. So I'm going to get my face out of the way here, and we're going over domain 5.4, given a scenario, troubleshoot common performance issues. Now, this one to me, as I was going through it, it's important. We have to know these terms. We have to know what they mean and things that we can do to prevent or monitor. But this is going to be one of those slides. I don't have a lot of CLI for us. I was thinking about going to my Ubiquity portal to show you some things when it comes to like the bandwidth, so we'll do that. But besides that, let's just get through these slides, okay? So what is network congestion? So network congestion occurs when network resources are overutilized, leading to slower response times and reduced throughput. We fix this with QoS, right? Essentially what this could be is that peak hours, we have high user demand. Maybe we need to upgrade a link, or maybe we need to apply QoS. When we have network congestion, that's when we do quality of service and we start prioritizing certain traffic, especially if this is happening during peak working hours. So we can implement QoS at layer 2. Typically, we want to implement this at layer 3 because where we see that network congestion is going to be outbound, right? Exiting our WAN interface. So that's where we're going to apply the QoS typically. And that's going to be how we troubleshoot network congestion. Now, we can have a couple different tools at our disposal. We can monitor it using something like NetFlow, exporting that NetFlow data to a centralized server, maybe our SNMP server like SolarWinds. Some devices like Ubiquity, they'll tell us that we'll get alert. We can set up alerts for high network utilization just internal to its own software, okay? Bottlenecking. So a network bottleneck occurs when a component of the network, router, switch, or one of the links, cannot handle the data load, causing delays and slowing down data transmission. So this is when our queue is getting filled up, right? So causes, underpowered network hardware, inefficient network design, application-specific demands, where certain applications or protocols are consuming excessive resources. Bandwidth top talkers can cause bottlenecking in our network. So troubleshooting, optimize the network design, do load balancing for certain applications. If it's to a web server farm, we're noticing it. Redistribute the traffic load. So balance traffic across multiple links. If we have multiple outbound links, if we upgrade our network topology to something like SD-WAN, that can prevent bottlenecking. Bandwidth and throughput. So let's go over these two definitions. Bandwidth is the maximum data. I like to think of this as the highway. A 4-lane highway, that's our bandwidth, the 4 lanes, right? And we allow speeds of up to 70 miles per hour. But throughput's what we actually are getting. Throughput is what we're actually getting, and bandwidth is our maximum amount. So I could have a 400 meg down bandwidth link that I pay for monthly, a broadband connection from Spectrum. But if I'm only downloading a file at 80 megabits per second, that's my actual throughput. Even though I'm supposed to be able and capable of getting 400 megabits, I'm only getting 80 megabits. So if we have some throughput issues, we're not getting the throughput we want, maybe that's QoS, maybe we hit up our ISP, maybe we notice our top talkers that are kind of utilizing the link for non-critical business applications. But that is the difference between bandwidth and throughput, okay? Latency. So what is network latency? So if you're a gamer, you know this very well because you don't want to game over Wi-Fi, latency, your lag, right? But what is it? So latency is a delay in data transmission, measured as the time it takes for data to travel from source to destination. So yes, we have bandwidth and throughput, and that's how much data we have per second. But our latency is the actual from user, client to server, and back, right? What is our latency? So low latency is crucial for applications that require real-time communication, video, voice calls, video conferencing, right? Online gaming. So causes of high latency. So laws of physics still apply, right? Distance. Long distance between devices increase travel time. The amount of network hops, how many hops we have in there. And then high traffic levels. So latency can also be affected by queuing, by the other things we talked about, like the network congestion. So troubleshooting. Optimize routing paths. Use low latency services. So if we just have a broadband connection, we might have higher latency instead if we have a dedicated circuit between our offices or something like that. And just upgrading. Going to fiber instead of having that coax typical cable connection into your house. Like our area, I just got MetroNet. It's awesome, right? My latency, my speed, my everything's better because I got fiber now. And then packet loss. I know, this is what network loss wants you to know. What is packet loss, right? How does it cause? Pretty much for everything we just talked about, right? If our throughput's high, overutilized bandwidth, network congestion, right? Well, so what is it? Packet loss occurs when data packets are lost in transit, often due to network congestion, faulty hardware, interference, kind of the things we've been talking about this entire domain, and can result in incomplete data transmission. So again, causes congestion, hardware failures. If we're over Wi-Fi, wireless signals, RF signals, tend to have a lot more packet loss than our wired connections. And that's because Wi-Fi, RF, it's in the air, right? There's a lot of things that can degrade that signal more, can attenuate it more, can refract it more, that can lose power more, signal strength more in Wi-Fi and wireless than we could have in a wired connection. Jitter. So let's talk about jitter. Jitter is the variation in packet arrival times, okay? So let's say every one of these red dots is a packet. We see our intervals here are evenly spaced. That's the X intervals here. That's what we want for smooth voice and video calls for real-time data. Jitter is when packets, data, let's say these, again, the red blocks here represent data or packets, are coming in an inconsistent order. And because of that inconsistency, it's going to affect our quality. You may hear the robotic talk like this, right? That could be due to packet loss, but jitter, right, can also cause that, where it's not a smooth stream, okay? So causes a jitter. High traffic causes delays, creating inconsistencies in packet timing. Network configuration, inconsistent routing or queuing policy, so messed up QoS. And network hops, a lot of paths, right? A lot of paths in our VoIP call. So how do we fix jitter? Again, QoS. And this is kind of common. We prioritize VoIP traffic no matter what, right? Because that's as real time as it gets and as critical as it gets for a lot of industries, right? Okay, wireless issues. So we did a deep dive in wireless, I believe, in Domain 2. But when it comes to troubleshooting wireless issues, a lot of common things we need to look at. So again, we have the three major bands that Wi-Fi operates in. 2.4 gigahertz, 5 gigahertz, and 6 gigahertz. Each with their own bandwidth channels, and each with their own common overlap. Now, where we see this happening a lot is in the 2.4 gigahertz range, though. With the 2.4 gigahertz range, we have 11 channels. Channels 1, 6, and 11 are the only ones that don't overlap, okay? And then we have channel 14 as well in there, but that's not common in like commercials, so we're not going to talk about it. But how do we monitor this? There's a lot of different tools we can use, a lot of different heat maps, Wi-Fi analysis tools we can use. What I'm going to show you in our next slide is just something called Insider. It's like N-S-S-I-D-E-R, Insider, very clever, by MetaGeek. That can just show us all the different Wi-Fi signals that my MacBook can see, right? And we'll show you that. A couple different ways we can monitor it, okay? We have signal degradation or loss. So this just could be a distance thing. This could be obstacles. So as we know, the 2.4 gigahertz range, because those frequencies are considered longer, right? Less cycles, right? They're not as tight. They require less power. They can go through objects a lot smoother, okay? Whereas 5 gigahertz, you get more bandwidth, you get increased speeds, but because of that, it can't go through objects as much, right? So there's a lot of different ways that signal attenuation degradation can happen. Distance, walls, floors, other electrical equipment, like they say, you know, your microwave, your 2.4 gigahertz range, it's not going to go through that microwave, right? You're going to get degradation. So how we fix this is by doing heat maps, by doing our wireless surveys and saying, where are our dead zones for 2.4 gigahertz? Where are our dead zones for 5 gigahertz? And do we have like 802.11r roaming? Do we have the ability to do, I forget what the actual term is, but switch from 2.4 to 5 gigahertz depending on where we receive the signal, okay? So insufficient wireless coverage. Do we have dead zones that we need to fix? We can look at this through a heat map. Roaming misconfiguration. So do we have good roaming set up? If we're in like a big wireless enterprise, we have lightweight access points, and we should be connected to the same SSID no matter where we are all those access points broadcasting that same wireless local area network on the same SSID? And do we have stuff like 802.11 configured for faster handoff between access points? Do we have these things, right? So do we have roaming set up, essentially? Do we have roaming set up for different offices? If we have clients that are going from different spoke offices on the road, like a technician, do we have that set up between those sites, right? So that kind of goes way deeper into how we configure our wireless local area networks, but something that we need to understand at least as a Network Plus certified individual. Then we have like some Wi-Fi attacks, so client disassociation issues. So if we were to do like an 802.11 packet capture, because wireless is not 802.3, it's 802.11, and if we want to capture 802.11 frames, we have to actually have that enabled. So like if I go on Wireshark right now, and I try to do a packet capture on my wireless adapter, which is what it'll do, I don't have the plugin enabled to do 802.11. So what's going to happen is it's going to pretty much emulate what it thinks an 802.3 frame would look like, which is kind of crazy, right? But if we want to look, this is like Ethernet, but this is wireless technically though. It's 802.11 frame. This wouldn't be a Ethernet 2 frame. So if we want to capture 802.11 frame, sometimes it takes additional equipment, additional software, and additional plugins, okay? Let's go back to our slides here. But a disassociation attack is where someone's sending 802.11 disassociation frames to disconnect our users, okay? Or it could just be something non-malicious and just due to interference, weak signals, or just... Okay, let me pause the video. I'm going to bring up this application called Insider just so we can take a look at some sort of Wi-Fi analysis. All right, we're back. So this is just a free app called Insider where we can actually see all the SSIDs. I'm in my small little office strip mall here. You can see these different bands here. We have 2.4 gigahertz down here. And we can see all the channel overlap here, right, between the different SSIDs that we are listening to. We get the 5 gigahertz range here. No one has the 6 gigahertz range. We can look at mine here. You can see where it's operating in. Looks like channel 6. You can see the overlap here of new SSID. And you can see some overlap here in the 5 gigahertz range as well. Just a simple and free app you can check out. You see the kind of security it has on there, the vendor it's coming from, Ubiquity, right? Utilization, amount of clients on there. So, pretty cool. Okay. Now, let's go ahead and do our quiz. All right, so we're on our academy here, our learning management system, where all of our courses are. If you want access to this, hit the link in the description below. Now, let's go to our Network Plus course. I'm going to come here to quizzes, and we're going to go to domain 5.4.1 quiz. That's going to be right here. Let me zoom in here. Get my face into the screen because I might want to use this for social media. And come on, it helps you guys, right? Seeing my face read these questions. So, question 1. In a Wi-Fi network, what is a common issue caused by channel overlap? That's interference, right? That's going to be interference in those channels. All of our questions here on our Academy site have an explanation as well. Pause the video if you would like to read. Question 2. When multiple devices on a network are causing high data traffic levels, leading to performance issues, what term best describes this condition? We're going to go with congestion. So that is A, congestion. There's the explanation if you'd like to read. Question 3. Which technique would be most effective for prioritizing VoIP traffic to minimize the impact of jitter? So VoIP traffic, right? Jitter. A and C could work, but if you have jitter, it's simply not like a bandwidth thing. Like, your throughput, what priority are you getting, right? So I think I'm going to go with C here. And yes, it is C. You can pause the video here to read the explanation. Question 4. What is the most likely cause of high network latency in a wired network? High network latency. Signal interference. So it's going to be A or B. And I think when we're talking latency, it wants us to know that's distance, right? That's a distance thing. So we're going to go with B. And let's go. We got it right. Pause the video if you'd like to read that explanation. Question 5. A network engineer notices that users are experiencing frequent disconnections in specific areas of a building. What is the most likely cause? I'm going to go with A, insufficient wireless coverage. The disassociation, right? They're disassociating because it's not strong enough. Pause the video if you'd like to read the explanation. Last question. Let's go. We're going to get that hunted. Which of the following could cause packet loss in a network? Packet loss. Let's see here. So again, I mean, low bandwidth. If we have low bandwidth getting overutilized, packet getting lost. If we have QoS misconfiguration, technically that could cause packet loss. But I think what this is trying to tell us here in the Network Plus exam is that, hey, network congestion is that's like the number, that's the foundation, right? If you're having network congestion, that maybe low bandwidth is the cause, So packet loss in general is just congestion on the network. So I'm going to go with D here. And let's go. We got that 100%. Pause the video if you'd like to read that explanation. And here is our results. So I want to thank everyone for viewing. Make sure you like, subscribe, share with your friends. If you're interested in getting our access to our academy or entering our live virtual training, hit that link in the description below. It's free for all Army, active duty, National Guard, and Reserve soldiers. Thank you for viewing. I'll see you in the next video.